Okay, this week we're talking about the dependent samples or paired sample t-test. This test will go directly towards your data that you're going to be working with. When you have collected your when you've done your demographic survey, it's been approved, you passed it out and got it back, and you have collected your before, pre-test, and post-test data. This is the first test you're going to run. Okay, so this is the paired sample t-test. You're looking at a pre-test and a post-test. You're basically looking at two scores, and it has very distinct um, areas that you have to look at and things that you have to do to place things in places. And once you've done that, then you'll get answers back. Because what we're doing is we're moving from the lit review and all the other stuff to a whole nother section, which is set up in the idea of we're going to be looking at the differences in the means. And if you remember, the mean is the arithmetic average. Okay, so we're going to be looking at
Yeah.
the arithmetic average for um, each of the answers, and then on top of that, we're going to be looking at uh, both sets of data. So in this case, I'm going to kind of go through this PowerPoint. Okay, so the background of this is there's no standard formula for calculating of t, which assumes there's no correlation between the groups. This is a test where we're testing a group of participants twice, in most cases, a pre and a post-test comparison. So we're doing a comparison just as we're doing for our project of before and after. And we're looking to see if there's an increase or a decrease. Okay.
Yeah.
On top of that, we'll be looking to see if there's an actual correlation between the two separate groups to see if there is a relationship. Because next week we'll be doing correlation. So when we look at correlation, we're looking at a relationship. So we're looking at the difference in the means and if there is a correlation between the two variables. So if you're looking at here and you look at these two, this is a test that's run on caffeine and no caffeine. Okay, if you actually look at this, okay, um, if you actually look at this, you're going to see that the caffeine, these are the hours slept. Okay, over here, these are the hours slept for no caffeine. If you look at this, you can just on a visual, because there's only 5 participants, there is only you can see that the no caffeine, they actually slept more hours. This is the basic write-up for it, okay? And we're going to go over this a little bit later when it's a little more detailed. But there was a significant difference in the scores for caffeine and no caffeine, okay? Now we're going to get back into a t-value formula, okay? So what happens here is that you're going to get a set of data, and all the data is going to be right in front of you, and I'm going to show you that in a little while. Um, in essence, we put all these numbers into SPSS. We run the paired sample t-test for caffeine versus no caffeine. And then data comes out, and you're going to get a mean and your standard deviation. For caffeine, you're going to get a mean and a standard deviation for no caffeine. Then you're going to turn around and you're going to get a t-value. And that number right here, the number 4, goes to the degrees of freedom. Okay, and degrees of freedom are in the comparisons. There was 5 participants, so 1 participant was taken out. Okay, and uses a standard to the other 4. So, and then you get a t-value. Now, this t-value goes to the same level as this p-value over here. So at that negative 566 is this actual t-value here. The p-value is something that's real important, and we'll get into that a little bit, but this is your significance level. It's either going to be above 0.05 or below 0.05, and that's real important to remember because it will be on your midterm. Okay? I'll be going over that in a little while. There is a slight non-significant positive correlation in this, and which was reported at 0.04. And again, there's also a p-value there that goes with it. That is, this one is greater than 0.05, so it's non-significant. Okay, so we're looking at a negative or a positive correlation. This will come into a little more of a understanding on a little bit, because I'm going to go over just a tad about correlations. Again, correlation is the relationship between two variables. Think of it this way. Me and my wife, right now, we have a positive correlation. Everything's going well. Either that or we could have a negative correlation where she's mad at me. Okay? So it's all about a relationship. That relationship is going to have this 0.04. This is a very, very weak correlation. Okay? And I'm gonna use the whiteboard to show you a little bit more about correlations in a couple of minutes. The results were suggested that caffeine had an effect when compared to hours slept. And this is the whole write-up. So you see a paired sample t-test was conducted to compare the hours of sleep in caffeine and no caffeine conditions. There was a slight significant difference, and you can read the rest of this. This is posted in the room, and it's also on the video that's in there. But you'll see that everything is there. The key in this one I really want to show you is right here, and that is if this section right here, these two lines tell all about your what you're testing. So you'll see that it was first off, it told you what kind of test, then what it was going to compare, and then it told you caffeine and no caffeine. So your first line in all of your write-ups are going to be all about what you're testing. Okay? Then there was a significant difference. Okay? In caffeine, and then you have to show the mean and the standard deviation for both. Okay? And then you'll have this t value. And we're going to go over that when we do we go through the first set of data. Then you're going to talk about the correlation right here, and then you're going to give a results and a conclusion. Okay, so the results suggest that caffeine had an effect when compared to hours slept. How do we know that? Okay, caffeine, it's kind of a negative connotation though. This low number for caffeine means there was a low number of low number of hours for sleep, whereas no caffeine had a high number. So caffeine did have an effect on the hours slept because that number was lower. Okay, so in all of the tests that we're going to be running from this point, all your numbers are going to be in your output. You're going to be placing the numbers in there, and you're telling a story that is in a template form for each and every test that you're going to run, and it's done the same way every time. There's no variation. So what you see here is a template that you'll then put your data in on multiple occasions. Right. There's the therefore statement. So this is the first test that you're going to run, and this is going to be basically your homework for the week. Okay, you have two papers, two write-ups you have to do. They look just like the one in the previous, not this one. You have two write-ups that'll look exactly like this. So if you take this, put it in, type it out, change the words, change the thing, and then you have to, of course, change the results because the results will be different. So we will be going through the volleyball one first, and then your homework is the oxygen one, and I'll show you everything before we are done. Okay? So, right now, I think I have a whiteboard. This is the actual data for the volleyball output that I'm going to show you. Okay? This is data that you would put into SPSS. You put one row being the preseason, one being the postseason. This test right here is run on volleyball serves, 25 volleyball serves that were performed prior to the season and after the season. What we're doing is we're going to look to see if there was an increase in their serving prowess by the end of the season. So I'm going to exit out of here, and to bring up this right here, and that's the wrong one. So to go, I didn't know I had the caffeine one. You'll see that the caffeine one, if I bring this back up next to the PowerPoint, if you can see the numbers on the screen, you'll see that the numbers correspond with the numbers here. So if we have caffeine, 5.40, and the standard deviation was 1.14. That's right here. Okay? You go to here, 9.40, which is the mean, and the standard deviation of 1.14, which is basically the same. Okay? So now here for your t value, why are the notes coming up that high? If you go to the t value, see how it's here, it says t, and then right on here it says at negative 566. That's what goes here, equal sign, and then you'll see the df has the number 4 right underneath it. So basically you're filling in the blanks. So that little t is italicized. Open the parentheses, put the df, whatever that number is right there, and then negative 566, comma, p is less than 0.05. And I use this one because 0.05, of course, is less than 0.05. So you're going to have a less than. Okay? So in retrospect, you now have a slight correlation at, and it's rounded up here to 0.04. Okay? Because in this one, you'd either put 0.038 or 0.04. And then you see how the significance here is above 0.05, it's 0.951. Now it's going to be p is greater than 0.05, because that's this number right here is greater than 0.05. So what I'm going to do is
We are like 10 students.
I'm sorry?
Oh no, sorry.
Okay. So if I'm going to make a new slide here, drawing. So to give you an idea, okay, slideshow from current slide. So to give you an idea of how this works, we're going to be looking at 0.05. That is the magic number to decide whether it is significant or not.
Okay.
Okay? So
Yeah.
if the number is above 0.05, it is non-significant.
How about 0?
So if I give you a number of 5.755, then that is above, so it's non-significant. And in the later weeks, we will talk more about significance and non-significance. But you just know
Yeah.
for the midterm, if it's above 0.05, it's non-significant. If it's below, then it's significant. Okay? So 0.000 is the best you can get. Okay?
Yeah.
Okay, you can't go any lower than that. And then you go all the way up to 0.05, and anything above 0.05, it is all non-significant. Okay? So that's how you would be writing it up. So, let's see.